Welcome to the Movement in Unity workshop. We're gonna pull up Unity, and when you create a project, be sure to create 2D instead of 3D because we're making a 2D platformer. You can name it whatever you want once it runs. Why is it asking me for this? Hopefully it's something I remember. Oh. I don't even know which email I used. Oh, hey, I got it. Alright, so create new project. And we're gonna create it in 2D. Oh, I did not even name it. Cancel it. Alright, well, it's called New Unity Project 2 instead of Movement in Unity, but that's okay. For you, just go to the downloads page, as usual, and download the newest one. All we've done so far is started creating a new project. Has anyone here done 2D anything in Unity? A little bit? Just played around with it a little bit? But no games? What kind of game did you try making in 2D? Start making? Was it like top down or platformer?
I started it last week.
Yeah. Well, what were you doing with it?
It basically just shoot a ball and try making it into a goal.
Oh, cool. So.
And then it like gravity pulls it down.
Yeah. Gotcha. That's cool. So it's not top down. It's actually side view of.
Yeah.
I like it. We are not going to download a new version because that would take an hour. Alright, so is everyone to this point? How are you looking? You almost to the point of making a new project? Make sure to make it in 2D as well. So some of the differences between 2D and 3D that you'll see, there isn't, the camera first of all is fixed so that the Z direction is kind of, you can't see the difference in it, and there is no directional light to begin with. In the other one, there's default lighting. In this one, all you have is the main camera, and just kind of has the skybox that looks a solid color rather than the 3D one that is not, kind of crappy looking skybox. But then I think it also sets some of the defaults to 2D stuff rather than 3D stuff, but you can still, if you click on 2D, you can make a 3D game still. Everything still has Z coordinates, and you can change the camera view around so that it isn't locked in the Z direction. And if you do a 3D game, you can change the camera so it is locked in that way, and it still is the same thing. It's just changing presets. Then we're gonna import, as usual, our custom package. Wherever you saved it. off of there. You guys are probably getting used to this by now. Yes, I use Visual Studios instead of MonoDevelop, so it'll be a little bit different looking up front. Oh, I should probably change my view so it's the default view. I'll switch that for you guys so it looks a little bit more familiar. So in this, I have the example, which is what kind of the finished product will look like. We're not going to be looking into that at all, but if you finish the workshop and for some reason you can wall jump and you didn't think you were supposed to be able to wall jump or something, you can look at the example code and see where the differences lie and change that on your own. Or you can just look back at that and look at the documentation and what different stuff means. Alright, so start us off, we're gonna make, well, first of all, we're gonna go to level 1. So go to scenes and click on level 1. Rather than the sample scene. And we're gonna create a 2D object. And we're gonna create a sprite. So what this does is it just creates, it's just like creating a cube, except it's creating a 2D sprite, and you have to give it a sprite. How I like to do this is by clicking on this little circle in the sprite render over on the right. There's a circle right next to that that you can click on, and we're gonna make a square because we're gonna make some ground first. So click on that white square. You can also drag it in from sprites. You can just drag that white square up to the sprite render. And we want this to be our wall, so we're gonna name it as such. I don't know about you guys, I don't really like white looking walls. So just click on the color, pick some other color, whatever you choose. And go with maybe some kind of blue wall or something. Doesn't look bad. So that'll be our wall. That in the game. And we want, so is everyone good up till now? Any questions? Alright, and then because it's a wall, we want to add a tag, or actually, oh, it's already imported. We want to count it as a floor, so that way when we're jumping around, we know that when we land on top of it, it is a floor and not an enemy or another player or whatever it might be. So change the tag at the top to floor. And that's just so that you can identify it from other places. We use that in some of the previous workshops as well. Now that we kind of have this, we can save it as a prefab. So just go to prefabs and drag it down here so that we can make more of them in the future. And just so we have a platform for our player to stand on in the future, let's change where this is. Just kind of extend it out so we can have something to work with for our player. just changing the transform, so you're changing the scale. You can either click in here itself, or you can type into the transform up here to change it directly. Both work rather well. If you want exact stuff, it's typically good to type it in here, but you can get a general idea just by dragging it around and moving it nearby where you are and then changing it to the exact location. So now that we have a floor, wall, whatever you want to call it, we can create a player. So we're going to do the same thing that we did with when we created the wall. We're going to create a 2D object that's a sprite by right-clicking over here, going down to 2D, clicking on sprite. We're going to name this our player. And we're going to change the sprite to our player sprite with his eyes and wonderful mouth. This is actually something I just grabbed off the internet. It has copyright 0, so we can use it. And if you want, you can go ahead and change the color of the player. Something else, give it a little character. That way, when we look at it, it'll look a little bit different. Everyone following up till now? Alright. Then, what we want to do, so right now, if we click play, we look at it, and the guy just kind of sits there, doesn't really do anything. He doesn't have physics at all. He just sits there. So what we're going to do is we're going to add some physics to him. By adding a component called rigid body 2D, because we're in 2D. What the rigid body does is it simulates all the physics for the object that is attached to, in this case the player. It has a lot of different things that go into it. So this top thing here, what this means, you have dynamic, kinematic, and static. Dynamic means that it can be, or it's affected by physics and gravity, and it's also affected by code changes. So if you tell it to change its velocity to go right, it will change its velocity to go right. What kinematic does is you can still change its velocity using code, but if you were to if we were to press play right now, you can tell that it doesn't actually have gravity in kinematic, whereas in dynamic it would have gravity. So another thing that it doesn't do is, because it doesn't have physics, if you run into something else and it's kinematic, it won't or if something runs into it, it won't move around because it is set to that position. It's only affected by code changes. So it's not affected by the physics engine of the game. What static does is it actually ignores both of those, and you can't change the velocity in code, and it can't you can't affect it by gravity either. Static is not very commonly used. Usually, if you want something to be static, you wouldn't even need a rigid body in the first place because you aren't using physics and whatnot. Although sometimes it makes sense to change it back and forth between like dynamic and static if you want. For example, in Breath of the Wild, the stasis power that you have, where you can freeze something in time and then hit it a bunch, and then after a certain amount of time it'll get launched. When it's frozen in time, that might be something where you switch its body type to static for that duration while you're hitting it, but it can still take, it still registers when you hit it and whatnot. So, uh, physics material we'll come back to in a little bit. Simulated just means is it essentially, does it exist? Or when simulated is off, it will not have any gravity or physics, or nothing will really affect it, the rigid body itself, but you can still see the object there. The object still exists. It's just, it's not a part of the simulation that, or the physics simulation that deals with all the collisions and gravity and the whatnot. So that's something you can just kind of turn on and off. If you want something to just go back and forth between the background, that's one way you can do it. Auto mass is just, well, mass is the mass of the object. It affects the gravity. Auto mass is just something that will change that based off of something else. And gravity scale is how much gravity is going into it. I think 1 would be your typical 9.81 or whatever meters per second squared going down. That's something you can play around with and change depending on different objects.
The gravity scale is actually based off of the settings in the movie, because you can change up the general gravity for everything else. Gravity scale
Oh yeah.
is great for when you want to go from 0 to, you just set it to 0.
Yep.
If you want to be heavier, you get your second down or something. So that's your personal gravity scale.
Yeah, that's a good example. So it's what you would probably want to change if you were swimming. You could just change the gravity scale so it's like half gravity, and then if you press up, you start going up instead of down, so you can swim or whatever. Then there is linear drag and angular drag. What linear drag does is when you're moving around, it's like the air resistance. So if you were moving in a direction without touching anything, it would still slow you down if you had linear drag because of it's essentially air resistance. What angular drag is it it slows down your rotation. So if you were spinning, it would slowly start to slow you down. It's also air resistance. Because of the game we're making, angular drag won't actually make a difference because we won't be able to rotate, but that's what it's there for. Collision detection, there's two different kinds. There's discrete and continuous. Discrete will only detect the collision where it is at that frame, because how Unity works is the velocity doesn't do a continuous velocity. It actually has you at one position, and then if your velocity is like a kajillion or like 1 million, you would suddenly teleport over there, and there wouldn't be anything in between, because it's going so fast. Every frame you would jump a considerable distance without actually ever being in those spots in between. What continuous does is it takes that distance in between and simulates as though you had run through it, so that way if you're falling down super fast, if you have continuous collision detection on, you can't accidentally like teleport through the ground and you don't keep falling. It will detect that collision and move you back up to where it was. That can be a little bit wonky if you're going really fast. Usually you should just avoid super fast falling like that. Sleeping mode, you can, this determines whether or not the object will start as awake or asleep. So if it were asleep, you can tell it does not do anything because the rigid body doesn't actually start working until you turn it to awake. You can also set it to always be awake, usually, or never sleep. Usually that doesn't make a difference between start awake and never asleep unless you have something that will change other things that come into it. And interpolate, what that does is it reduces choppiness. So if your physics is running at a slower speed than your graphics are, and like I said, your every run of your graphics or every run of your physics can like jump around like that. But if you have 5 frames in between there, it wouldn't make so much sense to have that because then you're kind of jumping around places. So what interpolate does is if you had 5 frames in between when you were over here and when you're over here, it would predict where you are in that time frame in between and project you on the graphics side of things so that it's more smooth. That tends to run a little bit harder on the computer because it has to do all these predictions. But that's based off of the previous places that you've been. What extrapolate does is it predicts where you are currently based off of the future places you will be. So it kind of goes ahead of itself and then backtracks. For most stuff that you'll be doing, probably won't make much of a difference because the graphics will probably be going about, won't be going so far ahead of your physics engine unless you have a really physics heavy game. And then there's constraints is the last thing. So if you freeze, for example, the Y position and we play it, we'll notice that we don't move because we can't move up or down. If you freeze the X position, you wouldn't be able to move side to side. And freezing rotation, so all that does is it prevents you from moving or rotating. So if you were to hit the edge of a floor, you won't be rolling off of it, you'll just be sitting on the edge of it. So we're going to freeze that rotation because we don't need our guy rolling around for this particular project. So you'll see if we run this, our guy just falls to the floor. That's not good. So what we need now is to add another component called the Box Collider 2D. And that just gives you a collider that detects whether or not you're running into other box colliders or any collider at all. So on its own, this won't do anything because there's no other box colliders to run into. But we can go back to our wall, and we're actually going to click on the prefab so that we change every wall that we make, and add a box collider here as well. And this, what prefabs do is it changes every instance of that. So this will also change our wall that we have out here, so it now has a box slider. And if we play it now, we'll have a floor. Because what I imported didn't have a smiley face. I don't know. We can change it. You go to sprite editor and add a couple extra pixels to make it smile or frown, whatever you want. Yep. You do not want trigger selected. Kind of be going over that in a little bit. So right now, we can play it, but we can't move. There's nothing we can do with it. So we're gonna add in some movement for our little guy here. Before we do that, I'm gonna move the player and make it a prefab, so that way we don't lose track of it. And we're gonna go to scripts and open up this player movement script, which is empty right now. And in this, we'll figure out all the movement for the player. And I use Visual Studio's, Jakey's Mono Develop. You can use whatever. Both work. It'll look a little bit different, but oh well. Does anyone have any questions so far? The rigid body stuff is kind of boring, but it's confusing if you don't know what some of that is, and you try changing it and thinking it'll do something, but it doesn't make sense. The only code I have is I had a blank player movement, and I had a script for the exit, because that way we can just kind of have an exit to restart the level really fast, or go to a new level if you want to. I wanted to give that to you if you wanted to play with it after the workshop. So in here, we're gonna go over some of the basics player movement. So we want to start just being able to move horizontally. And what we'll do for that is we will create a public move speed that we can change in the editor, or that's going to be a float, public float speed. And then in start, we're going to create a rigid body 2D rigid body 2D, and we'll just call it RB for rigid body. Or actually, up here we're gonna call it rigid body 2D. Sorry, RB. So we create an empty variable up here, and down in start we are going to set it equal to get component rigid body 2D. So what this does is it looks at our player, computer works, and it gets the component here that is the rigid body 2D. So now it has access to all that information that that rigid body has, and that's where we'll be setting the velocity, and so that way we can change velocity when we move. We're also going to add the private variable called, or float called horizontal. And this is going to be our horizontal movement that we get in update. And we get this from the input. So this will get access raw. We'll get our input for in terms of either -1, 0, or 1. There won't be any in between. That's different from get access. Because we're on a keyboard, you want to use get access raw because there isn't any in between when you're clicking a button, whereas a controller there is some stuff that goes in between that. I think it's called horizontal. So I believe so. Yeah, I'm gonna look at it really quick to double check. Yep. So that will get our horizontal, which is either A or D or left and right arrow. And that's just the default that Unity provides you. You can actually change those in the setting I just showed, but we're not going to go over how to change that for the sake of time. So right now, every frame, it will give us whether or not we're clicking left or right based on our horizontal. So what we want to do now is actually change the velocity of the player, and we want to do that in fixed update. So we're going to create this new private void fixed update. If you have Visual Studios, it'll probably start to autocorrect it for you really quick. And the difference between fixed update and update, you want to use fixed update will run at a certain time every single time. So every like 0.1 seconds or whatever, it will run. Whereas update will run every single frame, but depending on how intensive that part of the game is and how your computer is working, it'll change how long in between each frame. So anything that has to do with input or graphics, you want an update, but anything that has to do with physics, you want to put in fixed update because that doesn't rely on the graphics and it can keep a consistent time. So you have to have some kind of communication between here, which is why we're putting the horizontal in here, and then we're going to send it to fixed update down here. So what we want to do is create a vector2, actually, I'm going to open up something real quick. Oh. And we're going to call it target velocity, because that is how fast we want to be going when we're holding down the button. And we're going to set this equal to a new vector2, and vector2 is just an x and a y. So we want our x to be equal to our speed times our horizontal. So the speed will give us our magnitude of how fast we want to be going, and our horizontal will tell us which direction we're going. So forward or right or left or no direction at all. and that is our x coordinate. And then for our y coordinate, we just want to keep whatever we have, or for our y vector, we want to keep whatever we have. So we're going to access our transform dot position, or wait, is that position or, sorry, we're going to access our rigid body dot velocity dot y. So what that does is it access, or it gets whatever the velocity that it currently has and holds on or maintains that velocity for the up direction, but it'll change the side to side. And then we're gonna set our new velocity, so RB dot velocity equal to we're gonna use something called smooth damp. So we're gonna use physics.2d or physics2d dot smooth damp. Oh, unless I forgot how to. Oh, vector 2d. Okay, my bad. Vector 2d dot smooth damp. And what this does is it will create, or it will slowly ramp you up to whatever speed you choose. So if you move right, you don't immediately switch to right. It'll give you a time frame in which you adjust from what you're currently doing to where you're going to be. So we're gonna create, so our current velocity is what we put in first, so just get rb.velocity. We want our target velocity, which we have right above us. We just figured that out. So target velocity, and we're gonna just create a reference velocity, which is new vector 2 . Actually, we're gonna reference it from up here. So we're gonna create a reference up here. So vector 2 reference, and then in start we'll just set it equal to reference equals vector 2 dot 0. So this just makes it zeroed out reference because we don't need anything else for this. And we're gonna get that from down here. And then there's the amount of time we want it to switch in between. And we can actually make this another public variable. So the amount of time we want it to take to switch from where it is now to what the goal speed is, target speed. We'll call this public float move time. And we'll add that as the last parameter. Alright, now, is everyone good on that? Any questions? Yes?
We get an error on the first line of fixed update. It says vector 2 does not contain a definition
Does not contain. Did you?
Oh,
So we're just naming it target velocity. We're not getting one from them. So now we can go back here and go to our player prefab. And we can add the script that we just made called player movement. So now our player has this script attached to it, and we can give it a speed and the amount of time that we want it to move up, ramp up to that speed. So we can do that fairly quick, just 0.2 seconds or so. Now we can test it out and see if it works. Sweet. So a little guy moving around, and you can see if we move off the edge, we can. Oh, fortunate. Does everyone have their guy moving? Nope. Do you know what's going on, or
Not really.
just doesn't move any quickly? Did you make sure to attach the component
Yes, maybe I didn't.
and set the speed? Does everyone else have it going well? Sweet.
Yeah.
So move around now. Be kind of cool if we could jump too. So we're gonna add in some jumping next. We'll go back in here, and we're gonna add a jump speed that we can set outside. Yeah, like 10 will work for a jump speed. So create a jump speed, and we're gonna so once again, we need something to hold on to whether or not we press the jump button in between update and fix update. So we're gonna create a boolean. Boolean is just true or false, and call it is jumping. So if you press the button to jump, we'll set this to true. If you are not pressing the button to jump, we'll set it to false. So in update, we want to set this equal to is jumping equals input dot get button down, and then type in jump, because that is what our input name is for jump, and that's set to space to jump. So right now, whenever we press space, it'll set it to true, and whenever we let go, it will set it to false. And then in fixed update, we want to check to see if we're currently jumping, and jump if we do. So we want to have an if statement that checks if we are jumping. So if is jumping. So if is jumping is true, it will go in, or it will check this. And then inside of it, we will first set is jumping to false, and then we will jump. And what we're going to do for that is we're actually going to create a new method called private void jump. So all we have to do if we want to jump is access that method that we're about to make. And then inside of here, we want to just change the y velocity. We don't need to, or we can hold on to whatever the x velocity is. So we want our rigid body dot velocity to be equal to a new vector 2, so a new xy velocity, and we want our x velocity to stay the same, so we're going to get our current x velocity dot x, and then for the y velocity we want to set it equal to whatever our jump speed is, so set it equal to jump speed. Why is this complaining? Oh. Alright. And now we go back to Unity, click on our player prefab. Yeah. Does anyone have any questions on what I just did? All good? Now we have to go back, and because we added the jump speed, we have to change our jump speed. I think 8 is probably a good amount. If you don't see the jump speed show up here, be sure you saved your script, because sometimes if you forget to save, it won't update it in the Unity. And then if we play it, magically see our guy start to jump. What? Yep, we can still jump as much as we want though. We can fly off the map. So what we're gonna do next is to check. We want to check to see if we're on the ground, which is there's a few different ways you can do that. You can use the on trigger, so the same thing that you can use whatever it uses to check to see if it should keep falling. That's the on trigger with the box colliders. The problem with that is if you don't want to wall jump and you run into a wall, it will still let you jump right here because it will register that trigger. So you would need to make a different box collider that is only below you, and that kind of gets messy pretty quick, but you can make it work. Another way you can do it is with raycasts. I'm not going to get into that. That's probably not a good idea because it's a little bit confusing, and if you have a raycast straight down, it ignores the rest of your body, so you would need to do that in a different way. What we're going to do is the physics.overlap, which essentially just makes a temporary hitbox in a position that you tell it, and then it will check to see what's in there, and you can see if this is ground. So you make a hitbox right below you. You say, if this is ground, then we are grounded and we can jump. If not, we're not grounded and we won't be able to jump. So come back into our code. We want to set a new variable for grounded. So pool is grounded. And then because this only has to do with physics, it doesn't have to do with your input very much, except right here. So when we're jumping, we also want to make sure that we are grounded when we jump. So we're going to add in an if statement for if is grounded. And we're going to move our jump command into this if statement. So that way we only jump when we're on the ground. I don't delete it all. So right now we haven't set is grounded, but we're checking it to make sure that it's true in order to jump. And then we want to set is grounded equal to false before we check to see if it's equal or if it's currently true again. So we're going to set it to false just to reset it. So if you had fallen off the ground or something, it'll set it back to not being grounded. And then we're going to check to see if grounded is true right after that. And the way we're going to do this is by using the overlap box all. So we're going to get a collider 2D array. We're going to call it beneath. So what this does is it gets an array, or a list essentially, of all the colliders beneath you. That's our goal with this. And we're going to set it equal to physics, if I can type, physics, oh my, 2D dot overlap box all. And in this, we need to give it the center position of this box below us that we want to check to see if we're grounded. So we're going to give it a center position, so vector 2 for a point, and we're going to get our current point using transform dot x. So we have the same x coordinate that, or transform dot position dot x. So we have the same x as our player's x, and then we want to give it transform dot position dot y, so it has the same y, but then because we're checking below us, we want to just subtract a little bit off of that, so we're actually checking below where we currently are, rather than only checking inside of ourselves. So we're gonna subtract this by like 0.05 or so. Next, we need to give it the width and height of the search box that it's searching for the grounded stuff. So we want to create a new vector 2 that stores that width and height. For the width, we actually want to change it a little bit, and so we get our transform.scale, which gets the, or .local scale, .x. So this gets our current player's width, but we actually want to subtract a little bit off of this, just so we don't accidentally start wall jumping. We don't want to be checking for walls that we're bordering on the side. We only want to check below us. So we want to just subtract like 0.1 off of that or so, 0.1. And then we want to just use the same y that we have. So we're going to do transform.localscale.y. And then we need to give it a rotation, and we can just give it our a z rotation. Because we don't rotate, this doesn't actually matter. So you could just put 0. Actually, I'll just do that. So set the rotation equal to 0. So what this is doing is if we have our player, it's creating a box right here where the center point is a little bit below our center or our player's center point, and then the width is slightly less than our player's width. So that way it's collecting every item that touches this box, this dotted box, and it's giving us the collider for it. So the only time we'll get anything other than the player will be is if we have something right below us. So we can check to see if that's ground. So then we're gonna go into checking to see if that's ground. So we have our array, our list of objects below us. We called it beneath. So we're going to use a for each loop. So for each collider 2D C in beneath. So what this for each loop does is it goes through the list of 2D colliders that we have called beneath, and it will give us each individual one each time we go through this loop, and each time we go through it, it'll just be called C, which is what we called it right here for collider. So it'll give us each collider one at a time, and for each of these colliders we want to check to see if it is ground. So we want to see if this, or if or C, so the collider dot game object dot compare tag ground. So this is where that tag comes in. We're seeing if it's identified as ground. If it is, we want to set our is grounded equal to true. So if any of the objects right below us is considered ground, we want to be able to jump. Does that make sense to everyone? It's a little bit confusing.
Sort of.
With all the
Never
stuff.
seen a for each loop before.
Yep.
So is that where, like, the floor tag comes in?
Yep, that's exactly what it. So if you had named the floor tag, or actually did I name it floor? I might have named it floor. So we might actually need to change that. Oop. Yeah. So this is actually, sorry about that. So this should actually be floor instead of ground. So you could also get the tag and just see if it equals, if that string equals floor. But if you had done a mistake like I just did there and then ran the game, if I had put in ground, it would tell you, hey, there's actually no tag called ground. Why did you do that? So that it'll do that if you use compare tag, but if you just get the tag and check to see if it's equal, it won't give you any warnings like that. So using compare tag is generally a better idea. And I think it's actually more efficient too, so it tends to make more sense. But if our floor was not marked as such, then it would not let us jump off of it. So if we play it now, we should be able to jump, but then not again. Is everyone getting this? Sweet. Alright. Yep. So to illustrate that, I'm going to make another wall that's actually a wall and not a floor. I'm just kind of move it over here, drag it so we can see it. So this way we just kind of have a wall to work with. If you look right now, our guy sticks to walls and whatnot if we're moving. That's because our physics material has friction added to it, a lot of it. This is a common mistake that people make in one of their first games, is they don't change that physics material. So we're gonna create a physics material 2D. So if we go and create physics material 2D, we're going to call it frictionless. We do not want friction because we can already adjust the movement on our own. So as you can see, the base friction is 0.4, which is quite a bit. You can ramp that up or lower it with the physics material. For our purpose, we want it to be 0. But you can also do bounciness. So like your slime blocks in Minecraft or whatever, you can bounce off like a bounce house if you increase its bounciness, which is kind of interesting to play with. I'm not going to use it for this workshop, but this is how you would change that if you wanted that. So you right click and go to create, and then all the way down here is physics material 2D. And what we're going to do with that is we're going to go to our player, make sure our player doesn't have friction. So if you look at the rigid body in the player, you can add it right here. You can either drag it in like I just did, or click this little circle right next to it and click on frictionless. We just created a new 2D physics material. Wall? Is that what you call the physics material?
Yeah, I guess.
That works. Yeah. So attach that to your player. And yep. And then we also want to do the same thing with our walls. So if we go to our box collider and attach frictionless to our walls, right here, this will make it so both our player and our walls are frictionless. So when we run it now, we move a lot more smoothly and we don't stick to the walls anymore. We can up here, we can see our jump is working, but it doesn't let us wall jump either. So Right. I believe it's the angular gravity. That's a really good question, actually. What would happen if we? I think it might be the gravity, like, because you're still being pulled down, so it's kind of exponentially changing your velocity to this direction, but negating the y.
Oh,
So it kind of has its built-in friction just because you're being pulled down. If you were to have gravity turned off, I think you would just keep going,
okay.
even if you were pushing against the wall.
Gravity is very protracted, that you do a lot with it because everyone has their own modifier to it. You might have that information.
That's not what I'm gonna do. So I'm gonna make these a little bit bigger just so look more like a floor and a wall. And then I'm just gonna add in some more walls just for obstacles. And yeah,
How do we move the camera in case we want to scroll to the right or something?
that's a good question. We can actually just attach the camera right to the player, so it will follow the player. This is not the only way you can do this, but it's a simple way to not have to worry about it. If you use something like Jake did in the last workshop, you can make the camera movement a little bit more smooth so it doesn't go exactly. It gives you a little bit of leeway. But for our sake, this is good. So what we're going to do now is we're going to add some lava. So we're going to create another 2D object. New sprite. Call it lava. So create another 2D sprite on the side here. And we're going to give it that same sprite that we gave our wall, because it's just white. But because it's lava, we can color it red instead. We're going to put this lava over in our pit here. And on our lava, we want a box collider to tell if anything has hit it. Because if we hit the lava, we want to die and restart the level. So for a box collider, we want it to be a trigger because we don't actually want to bump into it. We just want something to happen when we go into it. So that's why we call it a trigger. When it's a trigger, you'll notice you can actually move through it. So you can use box colliders like this in order to like play a sound for passing a certain area, or if you want to be able to talk to someone when you're right next to them, you would use a trigger to box collider around that person in order to check that. And then we're going to create a new script. I'm going to call it Death on Touch. we're going to attach the script to our lava. We want to kill the player when the player touches it. Yeah, so create a new script called Death on Touch and attach it to the lava. Yeah. Yep. And all the code is in the examples as well. So I have a file there called examples that you can look at. And it has some notation on how it works too. Alright. So is everyone this far? Got the Death on Touch script? It's not displaying the lava. Did you add a sprite to your lava? Did you come over here in your sprite render? Add a sprite. So, like I said, stuff still has a Z coordinate, but the camera is just, the camera's at -10, so you set it to be right side by side with the camera, which is kind of weird to think about in 2D, but it still is a 3 game engine, so it has that. Alright, so now we're going to create our Death on Touch script. And we don't actually need our start and update for this, so we can get rid of those. So what we want is to use Unity's on trigger enter. So when something enters this box collider's trigger, or enter 2D, make sure it's 2D. So when something enters this box collider's trigger, we want to check if it's a player, and then if it's the player, we want to just restart the level, which will essentially be our killing the player. So first we want to check if it's a player. So if what collided with this, so other, I think collision is the default for this, but I like changing it to other so I know what it's talking about. So other dot game object dot compare tag is player. So if the game object of the collider that you ran into has a player tag on it, that's what this is checking for. Then we want to restart the scene. In order to restart the scene, we need to actually import something. So up top, we're going to use using Unity engine scene management, and this is used for anything that has to deal with scenes. So restarting a level or loading a new level would use the scene management. This is what the exit in our 3D platformer used the other time. And now that we have this imported, we can do scene manager load scene, and we want to load the same scene that we're already in. So I called it level 1. I believe you all have the same. So you can just type in the scene that you're making everything in. in this case level 1, and it will reload it when you run into it. So now we should have our Death on Touch working. So if we come back, if you haven't done it already, make sure that our lava has the Death on Touch script attached to it. Because otherwise it will not work. And then if we jump into it, our Pit of Doom, it should work or not. It does. What did I do? One sec. Maybe not actually. No, it doesn't. Alright.
On trigger enter 2D.
Yep. So make sure your player has the player tag attached to it. That's what I was forgetting. So we're using this player tag in order to identify that it's a player. So we want to make sure it's attached to the player. And then that way the lava will know that it's a player that's running into it and restart the level. Yeah. To the code? Sure. Is there any part of that that doesn't make sense?
Not working.
Make sure you import the Unity scene management too. If you don't have that, it won't. It's the same scene. Yeah, but level 1 is already. It worked for me. I don't know. It's just loading the exact same scene that it's already in. I think it should have. Wait. Do you have a player tag attached to your player? What's going on? Did you make sure to attach the script onto the lava? What's going on?
I'm having a problem with my code. It's for some reason not recognizing on trigger enter 2D.
Do you have a box collider on your lava? That's another thing that you need. That's a trigger. Make sure your box collider is 2D as well as your on trigger enter is 2D. How many people are still stuck on that?
Right, go on that like jumping. Yeah. You want oh is it first of all if you go to it would appear that's what I'm saying.
Colors can also be green.
You like this?
Oh, that, that's
You guys talk about it? Why don't we give it not letting it be the car? I just didn't know. Right above it, and another.
Alright, so now we're going to add in an enemy for ourselves. So you can jump on those. And so we're going to create another 2D object, sprite. We'll just name it enemy. And for this one, we can use our player sprite. And set the color to whatever you want. It's an enemy, so I guess we could do like orange or something. That's a bad looking color. And whenever we touch the enemy, we want to die, so we want to give it a box collider that works for that. But we also want, so this way our enemy will fall to the ground just like us with our box collider. Or wait, no, never mind. We need a rigid body in there too. So we need rigid body 2D and a box collider 2D. So that way our enemy will also use physics and fall to the ground just like us. Right now we can move it around, but we can't. We don't die if we hit the enemy. So we want to reuse this Death on Touch script and give it to it as well. But even this, if we run it, you'll notice it doesn't quite work yet. That's because our box collider is not a trigger, but we can't change this one because if we change this one, this is the box collider that we're using to make sure it doesn't fall through the floor. So we actually need another box collider for to check if it's running into the player. So for this box collider, we want it to be a trigger, just like our lava. So it's combining the rigid body and the box collider from the player with the box collider and the script from the lava, so this way, if we run into it, it'll restart the level, but it also has physics attached to it. So now, if we run into it, it should restart the level. If there's no physics, then you need a rigid body 2D. So on your enemy, you should have a rigid body 2D, a box collider 2D, box collider 2D that is a trigger, and a death on touch script. Now we want to be able to kill the enemy, so let's add a way so that we can jump on top of the enemy and kill it that way. Right now, if we jump on top, it just registers it as hitting it, and we die. So where can we check to see if we're jumping on top of an enemy? What have we done already that checks to see what's below us? So in our player script, we have our beneath list right here, and this holds on to all the box colliders that are right below us. So if we use this to check to see if there's an enemy below us, we can, in addition to ground, we can get rid of that enemy right below us. So right now we're only checking to see if there's floor below us, but after this we can actually check if it is a enemy right below us. Compare tag enemy, which we have not given it the tag enemy, but we can in a second. We want to, if it's an enemy, we want to destroy the enemy. So if we jump on an enemy, or if an enemy is right below us, we want to destroy see.game object, which is where the enemy is held, and that will remove the enemy from the game. Back here, we want to make sure that the enemy has the enemy tag. That way that registers. Does anyone have any questions up till here? Yeah. So this is in the player movement script. We're just and then I don't think this sometimes works. Yep. So it still doesn't quite work. The reason it doesn't work is because right now the box collider, it's saying we're running into it before we realize that we're jumping on top of it. So it's killing us before we kill it. So we actually want to change the size of the enemy's box collider, or trigger box collider, to make sure that it's only when we run into the side of it and not when we run into the top of it. So we're going to change the trigger of the enemy box collider to 0.5.
I was going to ask, like, if there's a way to make the enemy gravity while still being a trigger. Like, seems like I can only have one or the other.
Yeah, you can actually add 2 box colliders.
Okay.
So you can have a box collider 2D that is a trigger in addition to one that is not a trigger. So great. Now when we jump on it, it disappears. Does everyone have that? Your enemy does? So you need to add a second Box Collider 2D that is not a trigger. Yes.
So can you explain again how you did like the jumping thing where you kill it?
Yeah, so right where we check to see if it's a floor, we also check now to see if it's an enemy. And if it's an enemy, we destroy the game object. So these 4 lines right here.
Yeah,
What should a box collider do?
The trigger, because the trigger is what determines where the trigger is what the script uses to tell like if anything enters this or if anything collides with this trigger, we restart the level if it's a player. The other one is the physics one, so that's what uses or like tells like if there's ground below me, like stop. If there's something above me, don't hit it. So we don't want to resize the physics one, but the one that's a trigger doesn't involve the physics at all.
Smaller.
Smaller, so that way
I said like
that'll probably do. I think I just did 0.5 to be really safe because otherwise.
my character still dies when he jumps on the enemy.
So did you? So first of all, did you add the enemy tag to the enemy?
Yes, I did.
And did you resize the box collider that for the enemy, the trigger box collider?
Probably not. I don't know what you're talking about.
So the box collider that you made a trigger that's on the enemy, you want to resize it so it's about half the size. So that way it only triggers if you reach the side of it, but not if you jump on top of it.
Okay.
And
If you hit an upper side.
yeah, it's just destroy and you do c.gameObject, so it gets this right here is the box collider, the C, and it gets the game object that that box collider is attached to and destroys it. Feel free to look at the example code too if you're really struggling. In addition, like, so now when we jump on it, we destroy it, but we just kind of walk right through it and it doesn't really feel right. It just kind of disintegrates below us. So we can actually add it really quick to make it so that in addition to destroying it, we jump off of it. So right after we destroy it, we can just call our jump function, which we made down here, and it will jump as well. Just one more line. So now, when we go and jump on top of it, it will bounce off. So, is everyone to the point where they jump off of the enemy and destroy it?
Yeah.
Anyone not to that point,
I just
rather?
figured out why my lava was broken. The size was set to 0.0001 or something like that.
Oh no.
I
That'll
don't know
do
how
it.
that happened.
Yeah, that's kind of strange. How you magically that small. Alright. Yeah. So, slider, rigid body,